Earthing versus grounding, what's the difference? In low voltage and high voltage power systems, the terms earthing and grounding are often confused. But in engineering practice, these two functions influence fault current magnitude, transient behavior, protection coordination, arc flash energy, and system stability. Electrical safety starts with understanding these two concepts. Knowing the basics helps everyone stay safe. Earthing is the intentional connection of exposed conductive parts to the earth via a protective earth conductor. Its purpose is to maintain all exposed metalwork at equal potential during a fault and ensure that touch voltage remains within safe limits. These parts normally don't carry current and are there to stop the metal body from becoming live, keeping you protected if a wire ever makes contact with the metal surface. Everyday examples of earthing include the metal body of a washing machine, refrigerator casings, motor frames, and electrical panels. When a live wire touches a metal part with a proper earth route, the metal becomes energized for only a split second. The low-resistance earth route drives a large fault current that instantly trips the breaker or fuse, returning the metal surface to a safe, zero voltage, before anyone can touch it. Now that we've covered earthing, it's important to understand how grounding differs. Because grounding is the intentional connection of a current-carrying conductor, usually the neutral point of a transformer or generator, to earth, which sets the system's reference potential and controls how the system responds during an earth fault. All of these functions work together to ensure the electrical system remains stable, protected, and able to respond safely during faults or surges. Now that we've clarified the difference between earthing and grounding, let's move on to understanding how the system behaves during a fault and how the fault current return path is established. Although there are various grounding systems, fault current always returns to its source using the earth or protective conductor only as part of the loop. So when a phase or live wire touches a metal body connected to an earth electrode, the current flows through the soil back to the transformer neutral, allowing the protective devices such as MCB, MCCB, RCD to detect the imbalance and trip the supply. Once isolated, the short circuit fault must be located and cleared so the equipment can be safely returned to normal operation. In summary, earthing keeps exposed metal parts at safe voltage, while grounding stabilizes system behavior. Fault current ultimately returns to the transformer neutral, rather than the soil. Understanding this fault loop is crucial for proper design, protection coordination, and effective troubleshooting. If you found this video helpful, don't forget to give it a thumbs up and subscribe to our channel for more educational content. If you have any questions or suggestions for future videos, please let us know in the comments section below. Click the bell icon to receive notifications and stay updated.